It's a pleasure to be as part of this event today. I was proud to be the recipient of the Women in Innovation Award 2019. Give you a little bit of background on that. It was to create a benchmarking application for manufacturers where we could sense check some consistent KPIs upon which manufacturers could start to share best practice and make improvements around productivity. And that was across the board, utilizing our system, utilizing the kind of data that Jordan was sharing there. How can we take lots of disparate manufacturing processes and start to enable that best practice and feed them so they can become essentially more intelligent systems? So it was great to do that project. We learned a lot, and I'll share some of that with yourselves. But the key for us is, we are essentially, as a company, providing software to connect the kind of technology you've already heard about this morning. So, it's great to have that level of machine vision to really pull the data that you want to give that anomaly detection from the vision perspective. You also need to apply smart algorithms against the data that's coming through, but you also need something to deploy that intelligence back onto the production floor. Jordan talked a lot about alert systems and when to alert, when not to alert, etc. And where TotalControlPro comes in is to start to provide the data sharing systems so that small businesses as well as high value manufacturers can start to improve their process and adopt the kind of technologies that you've been looking at this morning. To really, it's not just about the high value OEM, but also the long tail of British manufacturers and global manufacturers that are supplying the products through to the end case. And we ourselves work quite closely with a lot of the detail composite manufacturers and those initial prototype creators, and helping them to streamline their systems as well. So I'm an absolute advocate for adoption of new technologies and for it to be available and accessible and affordable. And that means we have to get smarter about how we deploy technology as well. So we've heard of a couple of these things already. I wanted to look at the ways that AI can revolutionize manufacturing. We've heard about predictive maintenance and some of those algorithms today. We've heard about machine vision and robotics to some extent, so I'm not going to touch on those too much. But cost optimization is one of those first things. If we're going to really manage the resources of the planet, the resources of our manufacturing systems, then it's absolutely key to understand where our costs are building up and what we can deliver to address those. So, rather than kind of give you some solutions around this, it's really to start looking at where cost optimizations can be brought in and applying the same kind of things that Jordan was saying, where it isn't just a specific cost optimization for a specific manufacturing plant for a specific product, but more general improvements that can be made across the board. Ultimately, where we can respond to agile changes in the environment, market, all the things that we've been addressing recently, and start to create some efficiencies around that, then then manufacturers in a much better stead. So predictive maintenance you've heard about, the key of it is it's a huge growth area, and I think we've had some very, very excellent information on that today. Into the robotics, yes, you can have, we need to automate more, but where we have a challenge is we work with a company at the moment who are a high grade pharmaceutical with the amount of data that's required for QA data. They're actually working with them as they develop robotics to carry the paperwork that's required for production. Now, to me, that seems a bit, I know it needs to be done, but the reverse is, why do we have the paperwork? Sometimes when we're solving the big problems with a complex technology, we forget how can we reduce the simple stuff first to actually improve systems. So digitizing QA tests, digitizing test environments will actually massively improve the productivity of our manufacturers, but also give us access to conditional information to enrich the kind of algorithms that are coming from the sensor data. So if you've got sensor data giving you specific details about the machine environment and test information, and that's being validated by the test and QA reports from the production floor, you actually start to get far, far more enriched data. And that's something I'm really, really passionate about. That's also why I put in the digital consultant. So we talk about other areas of AI, but one of the areas that we want to work on is capturing the intelligence that's already on the shop floor. We know in manufacturing there is always a plant operator who can walk in and just by the sense and feel of the room or the plant that day, he can tell you how things are going to go. Now that is an extraordinary amount of sensor information coming in and learning. We want to be able to capture that, capture the digital flow of the workforce, how they operate. We have a great environment working with John Lewis Manufacturing. We track their systems, everything's in play. We did it the way they said it was done. And then in production, we found one particular operative had come up with a far more successful way of batching and combining manufacturing than any of the algorithms that have been thrown at it. We were able to capture that, plant that back into the system, and start to employ best practice across the plant. So, and again, machine vision, which you've heard successfully. And for us, it's absolutely key. In our system, what we're looking at essentially is contextualizing the data that's coming through. So you'll have a machine vision data capture area, and what it'll tell that is what am I actually looking for? What job is this? What client is this? What are the works diagrams or the work to diagrams and the test environments that actually should be applied to this item? And then you can start to test against that's the predicting. This is how it should look, and you can start to employ this what's actually there. So you're always in real time comparing what's required and what's being seen or what's being experienced at the shop floor level. So what all this does is pull together the area that we're really passionate about, which is production optimization. So essentially, we're looking at utilizing modern near to real-time manufacturing systems so you can collect and connect all sources of data in the production environment. So that's the sensors, the people, the cobots, the robots, any machine learning or machine vision opportunities as well, but pulling it all together so you create this enriched contextualized environment. We were very successful working on a predictive maintenance project on a large distribution center where we were doing predictive maintenance on motors for a conveyor belt, which is great. You can start to do that. You can do the anomaly detection. You can manage by exception. But one of the key areas is, what is the job load that's actually going through? Did we know the weights being applied of each unit going through? Were you dispatching multiple robots or were you dispatching multiple chips? So it's again contextualizing all the information so that you can start to create a more effective environment. Another example of this is working in remanufacturing. So where again we're passionate about making sure resources are utilized more effectively. When you start to get to some kind of production optimization, you'll get to a point where an application is going to be applied to a product. This is not necessarily in new production, but in remanufacturing where you are testing or repairing, at some point there's an economic as well as a physical viability of that repair. And being able to have cost optimization, fault detection, and then understanding what else is going to be applied to this item, you can start to say at the point of application of labor or a part or something else, is this any longer economically viable? And therefore continue or fail it at that point so that resources are managed all the way through. At the moment, best guess scenarios are what is being used. We can talk about what ifs, the best environments, and what's being used in high value manufacturing. But in most of the, 21,000 SME manufacturers in the UK, they are using best guess optimization, which is essentially someone going, oh, I think this is the way it goes. And when you know that, if you want to make 6 variations of the same product, there are more variations than cells in the body, how is it we're leaving those to the human mind to compute in real time? So how does this look? Essentially, we are looking to create we are creating and have a dynamic synchronized control system. So you have dynamic scheduling. This is the orders requirement through the shop floor. This is when it's scheduled. This is the information we know about predictive maintenance, what's required, what machines are going to be available. This is our information about our resources, so what's coming in through our supply chain, and our staff and employees and what's going on. And actually synchronize that process, um, which can be done in a very, very simple basis at the beginning, and then optimized through smarter and smarter systems as you start to build the data up, manage the anomalies, generalize the anomalies, create the alerts where they're required. If an alert isn't needed to a person but to a machine to turn on more effectively, or a line to redirect processes, or to a test system to change the boundaries upon which that test system is going in real time. This enables us to take the machine learning and deploy it effectively, actually in real time on the manufacturing floor. Because that's one of the things that are is most essential. While we're looking at what's possible, and this I very much had inside of my project in Women Innovation, I came up against, every manufacturer thinks their system is different. Every one manufacturer has these specific areas, but actually there were far more similarities between production processes, not products but processes, than we'd considered. We know it is possible to create a general product system that can be adopted and adjusted to suit specific manufacturing needs, and then start to take that learning, take that data, and refine, define, and continue to do it. Because at the moment, through a non-optimized system, we are helping manufacturers recover 10,000 hours of lost production, 15% increase in productivity, and 10% decrease in downtime through not deploying AI. So just imagine what could be possible with the right systems integrated and connected. Because ultimately, it's about adoption of technology. We want to enable adoption, have it be scalable, have new advanced technologies be able to be sat in with the technology that's there. So there's an ongoing improvement process for our manufacturers, not just a switch and change. That's the way that we can make long-term improvements and ensure the adoption of the digital technologies is there for a lifetime, and really helps to serve everyone. So I whipped through that very quickly, and I'm happy to answer any questions. But really, for us, the guys that we heard this morning, they are the key kind of cutting edge areas. What we aim to do is wrap that all up and have manufacturers take it on. Thank you very much,